OSIRIS-REx is NASA's first asteroid sample return mission. It launched in September 2016 on a journey to explore a near-Earth asteroid called Benu.
Scientists have unveiled groundbreaking findings from the samples collected from the asteroid Benu. NASA's OSIRIS-REx mission, which returned to Earth last month, has provided us with a glimpse into the 4.5 billion-year-old asteroid. These samples have revealed significant amounts of carbon and water, essential ingredients for life.
Already, this is scientific treasure. And I want to stop and think about what that means. That is how we think water got to the Earth. The reason that Earth is a habitable world, that we have oceans and lakes and rivers and rain, is because these clay minerals like the ones we're seeing from Benu, landed on Earth 4 billion years ago to 4.5 billion years ago, making our world habitable. So we're seeing the way that water got incorporated into solid material and then ultimately into planets. And not just Earth, but probably Venus and Mars also had abundant water as well. When I think of Benu, a lot of people that I meet just in everyday life, they're like, why are you so interested in rocks? Because rocks tell you a story, right? And it's the story of Benu and the history of the solar system that I'm most excited to unravel with the science program. And when we look at the materials, these clay minerals, these carbonates, you had a lot of water moving around in the early solar system beyond what we really expected from our meteorite investigations. When we look at meteorites, we think water moving in very tiny scales. But I imagine a world right at the beginning of the solar system, right in that protoplanetary disk, where you had a lot of ice and a lot of rock and metal and carbon, and radioactivity started heating these things up. And you got massive circulation, what we call a convecting ball of mud, hundreds of miles across, right? And it's in that environment that I imagine these carbon atoms going through the first stages to the origin of life. And to me, that's the greatest mystery that we're facing right now, is like, how do you go from a ball of mud to something that's alive? Like, what happens when you make that transition? And the deepest, desire is that we're going to make some progress in trying to figure out, what is it? Why is it that we are here? We're alive. We're conscious in this universe. It's such a gift that I hope everybody really stops and thinks about it every once in a while, no matter what your problems are in everyday life. The fact that you're alive and that you're aware on this beautiful planet is something you should be grateful for every day.
The significance of these findings cannot be overstated. Carbon and water are the fundamental building blocks for organic chemistry, which underpins all known forms of life. Finding life elsewhere would challenge our understanding of where and how life can emerge. It could suggest that life is more common in the universe than previously thought.
You find life on Mars, for example, which is looking more likely by the day. If you find microbes there, then there are two possibilities. One is that they evolved in the same place, because we know that life can survive interplanetary travel. So one idea could be that life evolved in one place, which may have been Earth, may have been Mars, may have been Venus even, and then got transferred, or it could have evolved separately. So the interesting thing after you discover life on Mars, for example, would be to understand whether it's the same, it's got the same structure, the same biochemistry, or different. It's very interesting to know. I mean, if it evolved separately, then it may be justified to say, well, anywhere that the conditions are right, then life must evolve. So that's a big question.
Different solutions have been suggested regarding the origin of life, yet none have been verified. The samples from Benu could provide clues that challenge or affirm current theories about life's origin. While Benu itself is too small to host life, understanding the presence and history of water in such bodies is crucial. The significance of water extends beyond being a solvent for life. It plays a pivotal role in geological processes, shaping landscapes and possibly creating habitats where life might thrive. By studying the diverse range of environments and planetary formations within our solar system, scientists are gaining insights into the potential characteristics and habitability of exoplanets in distant star systems.
The solar system consists of three major types of planet: ice giant, gas giant, and terrestrial. These are produced because the protoplanetary disk has different proportions of rock and ice, depending on its distance from the Sun. Terrestrial planets develop closer to the Sun, where the protoplanetary disk is mainly rock, whilst ice giants developed further away from the Sun, where the protoplanetary disk is made of ice. So what you see in the solar system is these different types of planet. And actually, we don't know yet whether our solar system is typical of other solar systems around distant stars. So our solar system, we have Mercury and Earth, Venus and Mars, which are essentially the same. And then we have Jupiter, Saturn, Uranus and Neptune, which are essentially the same. The gas giants made of helium and hydrogen, primarily hydrogen. So at the moment, we've discovered many more giants like Jupiter and actually bigger than we have terrestrial planets like the Earth. We're now at the stage where we can see the light from distant stars, and we can see it pass through the atmospheres of planets as they move across the face of the star. And that allows you to determine the chemical composition of the atmosphere of the planet. So it's thought that within the next decade or so, we may see planets of order the size of the Earth, but rocky planets with atmospheres, and you'll be able to analyze what the atmosphere is made of. And if you see oxygen in the atmosphere, then it's almost certain that that means there's life on that planet.
The Milky Way alone contains billions of stars, many of which are orbited by planets. If just a fraction of these celestial bodies contain the necessary ingredients for life, the implications are staggering. However, the jump from single-celled organisms to complex multicellular life is a significant one. On Earth, this transition took billions of years.
It looks like life began about 3.8 billion years ago on Earth, but it took at least 3.8 billion years for something like us to emerge. We emerged in the blink of an eye. So you need stability of a planet over billions of years, or certainly we did on Earth, to get complex living things like human beings. Although solar systems and planets are very common, it could be that stable solar systems and planets that remain stable over billions of years are extremely rare. And that might be one of the answers, actually, by the way, to the question, well, how many civilizations are there in the Milky Way galaxy? Very big question. Could there be other intelligent civilizations out there?
While many scientists believe microbial life could be common in the universe given the right conditions, they argue that the conditions for complex life are far more stringent and might be met in only a tiny fraction of places.
There's a famous issue in physics, astronomy, called the Fermi Paradox, which is named after the Italian physicist Enrico Fermi, because he pointed out that our galaxy is obviously enormous, 400 billion stars in the Milky Way, something like that. And the Milky Way has been around for 11 billion years, maybe 11.5 billion years. So there's been a lot of time, and there are a lot of places in the Milky Way for civilizations to rise. I mean, it would be, if it's easy, then it would be very unlikely that we were the first. You think what we could do move forward 1,000 years or 1,000,000 years, let's say we stick around for 1,000,000 years at this rate of progress, you can imagine what we could do. See, the Milky Way isn't so big that you can't envisage us traveling around it and essentially colonizing it on timescales of thousands of years, or millions of years certainly. So one of the big questions in this discipline of looking for extraterrestrial life is to ask, well, where are the other civilizations? Because there's been enough time for them to arise and presumably colonize the galaxy if they want to. And so we look for signs of intelligent life out there and we see none. So it's that's why it's called the Fermi Paradox, because it's very difficult to understand. I mean, one answer would be that it's very, very unlikely that intelligent life arises on a planet. So we may be verging on the unique. The other answer is that civilizations don't persist long enough, so they get to something like this stage and then destroy themselves by nuclear war or something like that. There's one signal, there's a thing called SETI, where we search for extraterrestrial intelligence, where we look with radio telescopes for signals. And there's one signal called the WOW signal that was seen a few decades ago. I can't remember exactly when it was seen, which has never been detected again and never been repeated and still remains unexplained.
This has led to a lot of speculation. While some argue it might have been an intercepted signal from an extraterrestrial civilization, others believe it could have originated from human-made interference or natural sources. The WOW signal remains one of the strongest candidates for an alien radio transmission ever detected. It has captured the imaginations of both the general public and the scientific community, serving as a landmark moment in the search for extraterrestrial intelligence. Even though it remains unexplained, it underscores the potential promise and challenges in the ongoing quest to determine whether we are alone in the universe.